Good morning, everyone. Welcome to today's hearing. Today we're going to hear evidence from Mr. Hugh Mahoney, who was the designer of the smoke ventilation system installed during the refurbishment of Grenfell Tower. Now, Mr. Mahoney is going to be examined by Miss Grange, but I'm afraid, again, Miss Grange isn't able to be with us in person, so she's going to conduct the proceedings remotely. And Mr. Mahoney also is not able to be with us in person, so we're going to be taking his evidence remotely. So the picture you get will be a little different from that which you would normally get when watching the proceedings of the inquiry, but I hope that things will go well without any great difficulties. So the first thing I must do is to make sure that we have contact with Miss Grange. Miss Grange, are you there?
Yes, good morning, Mr. Chairman. Can you hear me?
Good morning. We can, thank you. And I take it you can see us and hear us all right. Is that the case?
Yes, I can, very clearly.
Thank you very much. The next step then is to make contact with Mr. Mahoney. Mr. Mahoney, are you there?
Yes, I'm here. Thank you very much. And I can hear you loud and clear.
Oh, good. Good morning. It's very nice to see you. Well, as you know, Miss Grange isn't with us in the room, so you and she are both going to conduct this remotely. I hope that'll be fine. You might need to take a little bit of care not to talk over each other because of the very slight time delay that can occur in these matters. Right, now, Mr. Mahoney, I understand that you're going to make the affirmation. Is that right?
That is correct.
And you should have the words of the affirmation on the screen coming up now. Could I ask you please to read them out?
I do solemnly, sincerely, and truly declare and affirm that the evidence I shall give shall be the truth, the whole truth, and nothing but the truth.
Good. Thank you very much. Now, Mr. Mahoney, just to put you in the picture, you may know this, but we have a break during the morning and the afternoon sessions, roughly 11:15 and 3:15, whenever it turns out to be convenient. But if you would like to have a break at any other time, will you just indicate that and we can accommodate you without difficulty?
Thank you for that.
Right. Thank you very much. Well, if you're ready to go, I'll invite Ms. Grange to put some questions to you. Yes, Ms. Grange.
Yes, thank you. Yes, can you please give the inquiry your full name?
Hugh Malcolm Mahoney.
Thank you very much for coming to give evidence today and to assist the inquiry with its investigations. It's very much appreciated. I'm going to be asking you the questions today. If you have any difficulty understanding anything I'm asking you, please just ask me to repeat the question or put the point in a different way. And as the chairman's just said, if you feel you need an additional break over the ones that we normally take, please just let us know. Now, you've made 2 witness statements to the inquiry. Can I take you to your first statement? This is at PSB 401329. So there is your first witness statement. And if we go on to page 16, we can see that it's dated the 28th of September 2018. And is that your signature?
It is.
And have you read that statement recently?
I have.
And can you confirm that the contents are true to the best of your knowledge and belief?
They are.
Thank you. And let's go to your second witness statement. This is PSB 401373. There's the second statement. And if we look at page 15, we can see it's dated the 26th of March 2021. And is that your signature?
It is.
And have you read that statement recently?
I have.
And again, can you confirm that the contents are true to the best of your knowledge and belief?
They are.
And have you discussed the evidence you're going to give with anyone before coming here today?
No.
Now, I'm going to start by asking you some questions about your background, including your qualifications and experience. If we could look first at paragraph 10 of your first witness statement on page 2 of that, PSB 401329. So here you set out your qualifications. And you tell us, after leaving school, I completed an indentured apprenticeship with a company that was originally called Richard Crittall and Z.D. Burry Limited, now known as Crown House Engineering. This apprenticeship lasted 5 years and covered the design and operation of mechanical systems. And you tell us that you also completed a 4-year course at Technical College and hold a 632 City and Guilds qualification in heating and ventilation. Is that right?
That's correct.
In terms of that last sentence, are those separate courses? You say there's a 4-year course at Technical College and a City and Guilds qualification. Are they the same thing, or were they different courses?
Same thing.
Yeah. When did you undertake that training?
From 1960 on to 1969 for the next 5 years.
Yeah. And did this training cover anything about the design of smoke control systems?
No.
And have you undertaken any further professional qualifications or training other than what we see there in your statement?
No.
And are you a chartered engineer?
No.
Now, if we go to paragraph 4 of your first witness statement on page 1, in this part of your statement, you're setting out your experience prior to your work on the Grenfell Tower refurbishment project.
Mm-hmm.
And you tell us that you have worked in the smoke control system industry for over 35 years,
Mm-hmm.
developing and designing smoke control systems. Is that right?
Yes, that's correct.
And in terms of your employment history, is it right that your experience with smoke control systems began while working for Nuare Limited, a fan manufacturing company, in about 1983?
That's correct. New Air is the pronunciation.
Sorry.
Yes.
New Air. And then at paragraph 5 of your second witness statement, I don't think we need to turn that up. You say that New Air Limited had invented a smoke clearance fan that would work at certain temperatures, which you were then involved in selling to the market. Is that correct?
That's correct.
Yeah. And then if we can go to paragraph 11 of your first witness statement on page 2. You explain that you worked at New Air as a specialist smoke control, that was a specialist stroke control business, including as an in-house expert for 8 years after 1992. Is that correct?
Yes.
And then at paragraph 12 below that, you say that after working in a couple of interim positions, you then set up and ran your own business, Advanced Smoke Technology, from 2003 to 2010, which you ran with a business partner, yes?
That is correct.
And you also explain that during that time, you began working alongside PSB on some projects, and you got to know Martin Booth, the managing director of PSB.
That's correct.
And then after briefly working for 2 Dutch smoke control companies, you joined PSB in early 2013. Is that correct?
That's correct.
Now, thinking back to your time before joining PSB, so at New Air and, well, running your own business at Advanced Smoke Technology, and indeed those Dutch companies, did any of those roles involve actually designing smoke control systems?
Yes.
All of them, or
All
just
of them.
some of them?
All of them.
Yeah. Now, roughly what proportion of the work that you did on smoke control systems before you joined PSB was in a residential context rather than in commercial buildings?
More residential than commercial.
Right. And in terms of residential, how common was it for you to be designing a system for a residential high-rise building?
Less common than small rise because there were less high-rise buildings.
Right. So just approximately how many high-rise projects, residential projects, do you think you'd been involved in before you joined PSB?
Do you mean projects that were taken through to conclusion or just designing and tendering?
Well, let's put designing.
Designing, a lot. I couldn't put a number to it.
Okay. Now, while working at PSB, if we look at paragraph 13 of your first statement on page 3, just bring that up. You tell us that while working for PSB, that your job changed, this is in the last 2 lines, from commercial manager to technical sales manager during your time at PSB, but you tell us that this did not involve any change to your role or responsibilities.
That's
Now,
correct.
What products or systems does PSB design and sell?
PSB don't sell directly a product other than the controls.
Right.
So they would buy in other products that would form parts of the system. So I'm not sure what you mean by your question.
I see. In terms of design work, do PSB only work on smoke control systems, or do they design other types of system?
Only smoke control systems.
Yeah. And as commercial manager and then technical sales manager at PSB, what were your roles and responsibilities?
At that time, I was effectively leading what we call the above ground technical people, designing smoke control systems. And also I was, through my committee work, able to inform the company of any changes that were going on within the industry.
I see. So you were leading the above ground technical people on the design of smoke control systems. Were you yourself actually responsible for designing smoke control systems in those roles?
I was still responsible, yes. It was a very small team, so I was very active in design.
Yes. And that included residential high-rise projects, did it?
Predominantly residential, yes.
Yeah. And did you have dedicated designer roles within PSB for people beneath you?
No.
Anyone designing smoke control systems?
When you say below me, there wasn't a hierarchy. No one answered to me. I wasn't managing people.
I see. You were just part of a team
Yes.
that designed smoke control systems.
That's correct.
I see. And for those of you that were part of that team and were designing those systems, did PSB require you to carry out any specific technical training?
No.
And you also tell us in your statements that in February 2016, you left PSB and you moved to Colt Smoke Control, part of Colt International Limited. Is that right?
That's correct.
And what was your role at Colt?
Technical sales consultant.
And what did that role involve?
Designing and selling of smoke control systems.
So you were both designing and selling them?
Yes.
Yes. And is it correct that you then retired from work in December 2020?
That's correct.
Yeah. And were you designing smoke control systems for residential high-rise buildings from time to time while at Colt?
Yes.
Yes. Now, you also tell us in your statement about your experience on various committees who issue standards and guidance. Can we just look at paragraph 14 of your first witness statement on page 3? You tell us there, I've always been interested in smoke control systems and the regulations surrounding them. I have watched things develop and have also had the opportunity to contribute myself as the industry has evolved over the last 40 or so years. During that time, I was for many years an independent member of British Standards Institute FSH 25 Committee for Smoke Control Systems, and I also have a long history of involvement with the Smoke Control Association. And you tell us you held the post of chairman of the Smoke Control Association from 1998 to 2000 and had an active role in the association as a member of both the technical and plenary committees. And then if we look at paragraph 18, actually we don't need to go to it. In paragraph 18 of your second witness statement, you explain that British Standard Institute FSH 25 committee was responsible for reviewing any documents, information, etc., which was or could be related to smoke control systems. Is that right?
That's correct.
Now, can you just help us? What does it mean to be an independent member of that FSH 25 standard committee?
I was co-opted to the committee because of my background in stair pressure differential systems, and I did not represent any other organisation at all, so I was independent.
I see. And did you have a specific role, having been co-opted to that committee, once you were co-opted onto it?
Not initially, no.
And after a time, did you develop a specific role?
I was asked by the committee to take on the responsibility to represent the committee at SEN Working Group 191, subsection Working Group 6, which were for pressure differential systems.
Yes, great. I'm just going to come to that in a moment. Just in general, can we take it from your experience and your involvement with the British Standards Institute that you were familiar with the British standards that applied to smoke control systems?
I was.
Now, if we go to paragraph 21 of your second witness statement at page 4, here we deal with the point you were just mentioning. You say you were then proposed and accepted by the members of the FSH 25 to be the committee's representative on this working group 6, and you explained that that was the working group. You can go over. It was the European group responsible for drawing up British Standard EN 12106 Part 6 2005, which was titled Smoke and Heat Control Systems Specification for Pressure Differential Systems Kits. And you say at that time, the UK did not have a principal expert on that working group. And so I was asked by the BSI to take the position of principal expert for the UK on the working group. So can we take it from that you would be very familiar with that particular British Standard 12101 Part 6?
Yes, I was.
Were you also familiar with the practical guidance set out in Approved Document B on fire safety, insofar as that was relevant to smoke control?
Yes.
Thank you. Now, if we go to paragraph 9 of this second witness statement, this is on page 2, you tell us a little bit more about the Smoke Control Association. You tell us that the Smoke Control Association was established in 1987. It's part of the Federation of Environmental Trade Associations. It was originally called the Smoke Ventilation Association. And then you tell us that the SCA has members from a range of organisations which are involved in the manufacture, design, supply and fitting of smoke control systems and equipment. The organisation is run via several committees, each of which carries out a specific function. And is it right that you were part of the SCA from 1992 until you began your employment with Colt in March 2016?
That's correct.
And as a trade association, is it correct that the Smoke Control Association is effectively a group run by the industry, bringing together those with experience in smoke control systems from the industry?
That's correct.
And you also tell us that you were, as we've seen, that you were chairman of that Smoke Control Association from 1998 to 2000, and you continue to have an active role after that. And to what extent did your work as chairman of the Smoke Control Association relate to the design of smoke control systems for residential high-rise buildings?
That came later.
So when did that come, that work with the Smoke Control Association?
That probably, I can't remember when it started. It was probably about 2009, somewhere around there.
Right, yeah. Now, if we look at that Smoke Control Association guidance, first, if we look at the 2012 version, LFB 3059241, we could pull that up. This is the first edition, June 2012. Revision 1, June 2012. And if we look on page 2, we can see that you are a contributor, is that right?
That's correct.
Mahoney, you're the first in the list for Novenco Limited. Yes. And then if we go to the 2015 version, RBK 402932, this is revision 2 dated October 2015 on guidance on smoke control to common escape routes in apartment buildings, flats and maisonettes. And if we go to page 2, again, we can see that you're acknowledged as a contributor to the guidance. In fact, Hugh Mahoney is listed twice in this list, once for PSB Limited, 4 up from the bottom, and once for Fan Systems Group, kind of towards the middle of that list, 9 lines down. Mm. Are these both you? They're not two Mr. Hugh Mahoney's?
Oh, they're both me.
I see.
I must say as well at this stage that this document does not relate in any way to Grenfell Tower because it's post-dates it.
Well, it doesn't post-date the commissioning of the system, does it?
It is not an applicable document to Grenfell Tower. The documents that are applicable are those that are set at the date of the planning approval for the project, and this postdates that.
I see. So are you saying that you didn't pay any attention to...
No, I'm not saying, I'm just saying this document postdates it. It's not relevant to Grenfell Tower.
I see, but just to answer my question, are you saying you didn't pay any attention to this 2015
I was
guide?
aware of its contents. I participated in drawing it up,
Right.
so I'm aware of it.
And did you take it into account in any way in the design work you did on the Grenfell project?
In so much as it affected the design.
So that's a yes insofar as it affected the design, yes?
Yes.
Thank you.
But also it must be noted that the design didn't go forward as a design. It was a system improvement that was given, not a design. The design didn't get carried forward.
I see. Okay, well, we'll come back to that when we look in detail at your involvement in the project. Just thinking about those two versions of the SCA guide, we've seen that you're named as a contributor to both. How did you contribute to these two versions? Let's take the 2012 version first.
Well, you're part of a review group and looking at the information that's flowing that's going to be forming that particular standard. So you're reviewing everything.
You're part of a review group. Did you actually write any of the 2012 guide?
I honestly can't remember. I know I wrote parts of the original, but I can't remember 2012. But
Right.
certainly involved in reviewing it.
Yeah. And 2015, again, was your involvement to review but not to write any of it?
That's correct.
Yeah. And who was Fan Systems Group?
They were the owners of PSB.
I see.
As it's a trade association, the Smoke Control Association, members are automatic members if they're already trade association members under different names. So fan manufacturers would be able to sit on the Smoke Control Association, as with damper manufacturers. They weren't signed up and paying members of Smoke Control Association. They were automatically able to sit on it by being part of the FITA organisation.
I see. So does that mean that you effectively wore two hats on that body to represent Fan Systems Group Limited and to represent PSB?
No.
I see. Now, based on what you tell us at paragraphs 12 and 13 of your second statement, I don't think we need to turn it up for the transcript, that's page 3. Is it right that you were an instigator of the guidance in the late 2000s and the coordinator of the working group that produced the original November 2010 version?
That's correct.
Yeah. Now, if we go to paragraph 12 of your second statement, we can read on page 3 of your second statement. You say that the idea of the Smoke Control Association guidance was to provide individuals and companies with consolidated information about how to design effective smoke control systems. Is that right?
That's correct.
And you go on to tell us, if we can move down the page to paragraph 14, just below that, you say this, you say, until the SCA guide was published, practical guidance in relation to the design of smoke control systems was sparse. What little there was spread across several publications. The aim of the SCA guide was to bring the guidance from industry, professional and government organisations together in one place to assist individuals and companies involved in the design of smoke control systems to be installed in apartment buildings. The guide also provided details and gave recommendations not previously covered in other standards or codes of practice. As we explained in the introduction to the SCA guide, whilst there were some prescriptive methods of providing smoke control, these methods could not always be implemented, and it had become necessary to develop performance-based solutions to improve conditions within common escape routes. So that's your explanation really as to what the rationale was behind the SCA guide, is that right?
That's correct.
Thank you. Now, I want to turn now to PSB's initial involvement and your initial involvement in the Grenfell Tower project.
Right.
If we look at paragraph 16 of your first witness statement on page 3, you say that you first became involved in the project in or around April 2014. That's in the first line. Now, can you recall, how did you become involved in the project? Who was it that contacted you?
I was contacted on the phone by Max Fordham, who explained in that conversation the system that he was working on, or the building he was working on, and that he had to either reinstate the existing system as it stood, but his preference was to increase upon that because he wanted to include a system of environmental ventilation within the common lobbies. That was the basis of that initial introduction, plus what restrictions were in place through the employer's requirements for the project, which were that we were to reuse the existing shafts and wall openings, and there would be no further changes to the system.
Yes, I see. And when you say that you were told that you were to reuse the existing shafts and wall openings, is that something that Mr. Smith of Max Fordham told you in that first conversation?
Part of the employer's requirements for the project, yes.
Yes. And what became your role on the Grenfell project?
At that time, we were just being asked for some free advice of what we thought could be done.
And subsequently, what occurred? Were you appointed as the designers of the project, of the smoke control system?
We weren't appointed until much later. At that time, we went back to Matt with advice, and that was it was impossible to install any system at all that complied with any current codes of practices, regulation or guidance. It was absolutely impossible because of the employer's guidance restrictions. Therefore, we put forward a suggestion of an alternative design solution that met the spirit of the requirements because we could not meet the requirements. And that was the second conversation.
Sorry, you say that was the second conversation you had with Mr. Matt?
When we effectively reported back on our findings.
I see, yeah. Now, is it right that your discussions about the new smoke control system began with Mr. Cross Smith of Max Fordham, but then from late 2014 onwards, you were reporting to J.S. Wright? Is that right?
No, we were not involved in the project whatsoever.
Sorry, when you say no, we were not involved in the project whatsoever, what do you mean by that?
Well, we were not contracted, we weren't employed, we weren't paid, we were just being asked for advice. And that's what we gave.
Are you saying this is just initially, or are you saying later that's what occurred?
Initially and later. We didn't get involved in the project as in we were now involved much later. We were only being asked for advice.
I see. Now, if we go to paragraph 35 of your first witness statement on page 8. You say this, you say, in the end, however, PSB was only contracted to design the system, supply a limited number of specific equipment parts and commission the system, rather than entering into one overall subcontract. J.S. Wright ended up placing a series of separate orders, starting with the order to carry out the design work that was placed in May 2015. PSB was not contracted to install the system. I understand that the installation was instead carried out by a company called RJ Electrics, which is a subcontractor of J.S. Wright. And we were not, in the end, asked to perform our works in phases. So that's the explanation you give as to how you ended up being asked to carry out the design work, yes?
Yeah, but that design work actually is the expansion of the design written down in the performance specification to a working system, not design as in what you think it means.
Well, I don't know whether you know what's in my head, Mr. Mahoney, but what do you think I think it means, the design work?
You're starting at the very beginning with a blank piece of paper and designing a system.
I see. So you're saying you didn't do that. It is what you're saying, that you took the design intent that was set out by Max Fordham in the employer's requirements and develop that design?
I'll go back to a statement I made earlier. The design that we had proposed was not carried forward. What happened was that Max Fordham reviewed the information that we provided them with to say you couldn't install a compliant system. It was impossible. That therefore, in order to find a solution which entered to the spirit of the guidances, not compliant, we put forward a suggestion of a system. That was not taken up. What they then did was to take the volumetric flow rate that we had specified and put it forward as an improvement to the existing system. And that was how the project went forward. It was on developing an improvement, not a design. And they did a document that they sent through for approval by Building Control, who approved the betterment.
Right, I see. Well, look, we're going to come to the specific documents that you prepared in due course, but I think I understand your answer at this stage. Just going back to what you said in that paragraph that I just read out about the fact that it was a company called RJ Electrics that would be installing the system. In your experience, was it typical that PSB would be asked to design but not install a smoke control system?
Not typical, but not uncommon.
Did you ever have any concerns about somebody else, i.e. RJ Electrics, installing the system?
Yes. So I had put in a statement within our proposal, which was accepted, that we would send our controls experts to site once they'd installed the first couple of modules to benchmark it and to check that they were installing it correctly and it was being wired in correctly, so that they could then use that as a benchmark for the continuation of the project. So yes, I did have concern.
I see. And is what you're saying that wasn't taken up, that proposal?
That proposal was taken up, and we did send engineers to site when the first few modules were installed to check they'd been installed correctly.
I see. Now, in his witness statement to the inquiry, Mr. Matt Cross-Smith of Max Fordham says that he telephoned PSB at the end of April 2014 to ask about the design of the smoke control system for the submission to Building Control. Now, I think from what you've said earlier that it was you that spoke to Mr. Matt Cross-Smith at that point, at the end of April 2014. Is that correct?
Correct.
And can you tell us what was discussed in that phone call?
Yes, to repeat that we were told what the working brief was. We were given a brief that they had to work in, which was the employer's requirements for the project, which was to refurbish the existing system and bring it back to an operational system, or to offer some development to improvement. And during that conversation, we were also told they wanted to maximise the system to incorporate an environmental system as well as smoke. And I said at that stage, let's look at the smoke side first. Let's see what we can do. And I do recall saying in that conversation, the original push-pull you were talking about is not going to work in the way we would need it to, given the restrictions we've just been told, and that we would look at the information he was then to provide, because we asked for further information. We would review that and get back to him with our proposals.
Okay. I'm going to come and ask you in a moment, come on to ask you about the push-pull proposal and your concerns about that. So I'm just going to come to that in a moment.
Okay.
Before we do, if we go to paragraph 16 of your first witness statement on page 3. Now, you tell us in this statement, 4 lines down, you tell us that Fergus McGregor, who was a system designer who worked for PSB, had already had a brief discussion with Mr. Matt Smith about this potential job previously, back in 2012. Is that correct?
Correct.
Now, can you confirm that Mr. McGregor was a system designer for PSB, yes?
Yes.
Rather than a commercial manager, yes?
Yes.
Can you explain why was the project assigned to you rather than Mr. McGregor from 2014 onwards?
On the day of the phone call, Mr. McGregor was not in the office and I took the phone call.
I see. So simply because you'd taken the call in 2014, you then carried on with the dealings with it, yes?
Yeah.
were you provided with any update from Mr. McGregor or Max Fordham about the previous discussions that they'd had about the project?
An update.
Yes. Did you, when you got off the phone to Max Fordham, did you speak to Mr. McGregor and say, what have you already been discussing with them previously?
Yes, I had a when he was next in the office, we got together and I went through, or asked him to go through with me what he'd been talking about. And at that stage, it was just, again, another telephone conversation with information taken down over the phone and no real detail.
I see. Is it right to say that the previous discussions between Mr. McGregor and Max Fordham had been more than just a brief discussion about a potential job and involved some preliminary design advice being provided by Mr. McGregor?
Not directly, no. It was a case of he had a phone call. He was told how many floors there were, and he was asked what kind of system could be put forward. He was told what was already there. So he decided push-pull was a better solution because of the extended travel distances within the lobby area, and decided that was the best system put forward. But he was not given the employer's requirements at that stage, which added the restrictions that meant you couldn't use that system.
I see. Well, let's just look at an email from Mr. McGregor. It's at MAX 403366, and I want to look at page 2. This is an email dated the 9th of November 2012, and it's from Mr. McGregor to Mr. McQuat, Andrew McQuat at Max Fordham. And you can see in the first line, he says, further to your email below, assuming the fans are okay and meet with the requirements, I can see nothing wrong with the proposal. And if we look at page 3 of this clip, we can see from the previous email from Mr. McQuat at the bottom of that page, and we can see it in the first line, that Mr. McQuat had sent a sketch schematic of the proposed smoke ventilation control at Grenfell Tower to Mr. McGregor. Mm-hmm. And I think you've already mentioned it, but is it right that Max Fordham's proposal was what you've called a push-pull, fully mechanical extract system?
That is correct.
And by push-pull, is it right that what this meant is that fresh air is drawn from the outside via the south shaft vents, and then air is extracted from the lobbies through the north shaft to the outside with the use of fans? Is that correct? That
is correct. You push air in on the one side with a fan and pull it out on the other with another.
So you're pushing air through the south shafts and then you're pulling air out of the north shafts.
That's correct.
Push-pull. So were you told about this early advice that had been given by Mr. McGregor when you became involved in the project?
Yes.
You were. Now, just some questions on the existing system that was already there in Grenfell Tower. In your first statement at paragraph 17, I don't think we need to go to it, you tell us that to understand how the pre-existing smoke control system worked, you visited Grenfell Tower and you considered some information from Max Fordham. Now, can you help us? When was your first visit to Grenfell Tower?
Gosh, I have no idea. I can't remember.
And approximately how many times do you think you visited the tower between 2014 and 2016?
Twice.
Twice?
Twice.
So you remember visiting twice? Yeah. If we go to PSB 50703, and look at the foot of page 1, at the very bottom, we can see an email from Matt Smith, Max Fordham, to HM at PSB. Is that you, HM?
That's correct, yes.
It's dated the 2nd of May 2014. And if we go over the page, we can read, he says, morning, Hugh. Thanks again for taking the time to discuss the refurbishment of the smoke extract system I'm working on. I'd like to clarify a few details from our conversation, if that's all right. I've attached a floor plan of a typical residential floor, our previous smoke extract schematic, a rough and ready marked up schematic showing my understanding of our conversation with the addition of general ventilation provision and a few photos for reference. The building is Grenfell Tower in North Kensington. And then he gives you some measurements in the next paragraph of the measurements of the supply shafts and extract shafts and the grills. And then he asks for clarification over a number of points arising from your discussion. Now, do we take it from this that you had spoken to Mr. Crotts-Smith by telephone on the 1st of May 2014?
Yes.
And can you remember what was discussed in that call?
That's the one I've referred to, where we were told what the employer's requirements were, and that's confirmation of it. The size of the shafts and the wall openings, etc., and the restrictions that would place on any proposals. And in that conversation, as I say, I've mentioned to him the push-pull is not going to work with that arrangement.
Yes. And again, I'm going to come on in a moment to look at your concerns, which you've set out in your statement about why you didn't think push-pull was going to work.
No, it's not just push-pull. There was no system type that you could install, given those restrictions, that complied with any current standards or guidance.
Yes.
Not any system type.
Okay, I understand that's your evidence. And again, I'm going to take you to the sections of your statement and ask you where you explain that. So I am coming to that. Now, is this the information from Max Fordham that you refer to in your statement, this information that you're being provided with at this time by Max Fordham?
Yes.
Yes. Were you provided with any other documents about the existing system?
There was a typical floor plan.
A typical floor plan. I see. And did that have measurements on it?
No.
No. You say in your statement that there was not much in the way of documentation. Was that a concern from your point of view?
Yes, I did during the course of the conversation ask, is there not a fire strategy for this particular project? And I can't remember the precise wording, but it was something effective. Well, there is, but there's not much in there. There was talk of, I think, 10 air changes, 15 air changes, and 30 air changes as a way forward. Conversations of that nature. We also discussed the reuse of the shafts. Were they suitable? Were they acceptable? Had they been inspected? Yes. And he sent a photograph to show the construction method, for want of a better term, and the grill type. So that was the information we had. The grill type, the construction type through photograph, and the size of the shafts and the wall openings, and that typical floor plan. That was what was. But
Yes.
yeah, I was concerned of the lack of information, yes.
I see. And you say he mentioned a fire strategy, but he said there's not much in there. Did you ever get to see that fire strategy?
No, the only documents we had are the ones I just referenced from that conversation.
And did you ever ask to see that fire strategy, even though you were told there was not much in there?
I did suggest that anything that was relevant be forwarded to us.
But did you ever ask to specifically see the fire strategy for the building?
In that statement, yes. Anything that was relevant should be forwarded.
I see. Was there anything particular in your view that was missing from the documentation that you were provided with?
Missing in what way? That was all that was provided, so there's nothing missing. What do you mean?
Now, you tell us in paragraph 18 of your second statement, if we could go to that, page 4. You tell us that the I think that must be a wrong reference. You tell us in your statements that the existing system was a natural ventilation system with a mechanical boost function. Yes?
That's correct, yes.
Yeah. Now, I'm just going to bring up a diagram from Dr. Lane's phase 1 presentation. I just want you to explain how the existing system was meant to work. This is a BLA 405481, and I want slide 173. So there we have a slide that Dr. Lane prepared at phase 1 of our work. In very basic terms, just explaining the operation of the existing smoke control system at Grenfell Tower.
That's not my understanding of the original system.
So
the original system, as told to me, didn't have a supply fan. It only had an extract fan.
I see. So is what you're saying that you didn't understand there to be where we've got at the bottom left, airflow and a red line to a fan at the south shaft level, at the south shaft entry point. You didn't understand there to be a fan there. Is that right?
That's correct. That's not how the system is explained to us.
I see. So did you understand that the airflow would go in purely based on natural forces?
That's correct.
So it would go in, it would enter naturally at that lower point, rise up. It would go through the particular lobby where the smoke control system was activated, yes?
Yes.
Because those dampers would be open on that one level, yes?
Correct.
And then smoke would be drawn up the shaft. And is it right that the primary intention was that it would be drawn up naturally, but that there was a fan that could be used by the fire brigade as a boost to mechanically support that movement of smoke, yes?
Yes, as we understood it, it was a natural ventilation system with no fans operating when the detection went off. When the fire brigade arrived at its point of intervention, they had the facility to turn a manual switch that would bring a fan into operation if they deemed it necessary.
Yes, thank you. That's helpful. Did you know how old the existing system was in the tower?
We were told it was an early 70s built building.
So you assume that the system was also early 70s, yes?
Yes, because the actual shafts were part of the construction of the building.
Yes. And was that system, that existing system, was it working when you first visited the tower?
No.
No. So you weren't able to see it in operation in any way?
No.
Did you ever consider whether the existing system was compliant with the standards in force at the time it was installed?
No.
Did you ever ask yourself what the original requirements might have been for that system?
Yes.
And what conclusion did you draw from?
Well, it was very difficult because I've never seen anything that small that was compliant with any standard. So to me, it was some hybrid design that someone had carried out, and there was no detail of it. There was no information available on file anywhere, as far as I can gather, because we did ask the question, that no one was able to trace the design aspect of that particular system of what it was supposed to fulfill, because in modern standards, it wouldn't fulfill anything.
No. Were you aware that the existing system was not compliant with the standards in force at the time it was originally installed?
Yes.
Let's just look at something on that. If we can go to Dr. Lane's phase 2 smoke control report. This is at BLARP 2, 5035, page 44. And I want to look at paragraphs 3.3.28 onwards. It's in the second half of that page. So this is compliance of the original system. So Dr. Lane tells us that in the paragraph below that, in natural ventilation mode, the aggregate area of the smoke shafts on each side of the lobby was 0.48 metres squared. And the aggregate area of the dampers on each side was 0.28 metres squared. These values are both significantly lower than the equivalent free area recommended by CP3 1971
Correct.
of 1.5 metres squared when automatically opening. Do you see that?
See that? Yes.
And she goes on and she looks at some other considerations as well. And she says at 3.34 at the bottom, therefore the system did not comply with the requirements of CP3 1971 due to the aggregate area of the dampers being lower than the equivalent free area recommended by that standard when automatically opening. Now, is that a conclusion that you also came to at the time?
Yes, it was totally inadequate.
Did you specifically think about the CP3 1971 guidance and whether the...
Not specifically, no. I just knew that it should be 1.5 square metres.
I see. So I think what you're saying is you didn't consider the CP3 71 guidance specifically, but
I wouldn't.
You knew, did you just instinctively, you knew that
I knew it wrong, regardless of what standard you were looking at.
Yes, because the smoke shafts were too small, yes? And the aggregate area of the dampers was too small, yes?
Correct.
Yes. Did you ever ask yourself what level of performance the existing system would have if it was working properly?
I took a view on that, yes.
When you say you took a view on that, what do you mean?
Well, the most efficient aspect it would be with the fan operating pulling. And it was obvious from the construction of the fan type, because it was a bifurcated fan, it would have limited volumetric flow rate. And given the diameter of that fan and given the size of the ducts, you could evaluate fairly accurately the likely volume flow rate.
I see. And did you ever produce any form of written analysis which set out your conclusions about what the existing system was capable of producing if working?
No, that wasn't in my brief.
Would the existing system have provided protection to the stair when working properly?
No.
Why did you think that?
Because there wouldn't be a sufficient ventilation rate to protect the stair.
Would the existing system have provided protection within the lobby that it had activated on when working properly?
No.
So you thought that the existing system wouldn't provide any protection to the stair or the lobby, is that correct?
I wouldn't say any, it wouldn't provide satisfactory protection.
I see. And which of those two was it intended to be protecting, did you think? The stair or the lobby, or indeed both?
I would say the lobby.
Yeah. Now, if we can go back to the email thread that we were looking at earlier, PSB 50703. And if we look at page 1, this email is an email from Mr. Cross-Smith to Fergus McGregor at PSB, and you are copied in to this email. We can see that you're CC'd. It's dated the 2nd of May 2014 at 10:59. And he says, morning, Fergus. I understand you're the person to speak to regarding the residential smoke extract system in Hugh's absence. I spoke to Hugh yesterday about a refurbishment job in London, which I believe a colleague of mine in our Edinburgh office has previously discussed with Jim Shields. We're looking to bring the existing non-compliant push-pull system up to scratch. And after speaking with Hugh, it seems a pressure differential system would be the way to go. I've recently been informed that a deficiency notice has been placed on the building due to the existing system being inoperative. This expires on Monday. For this reason, I'd like to have a chat with you to clarify a few points made by Hugh, and also to see if you may have any ideas for interim measures on the existing system. So can we take it from this that Fergus McGregor was still working for PSB in May 2014?
He was.
And if we look at paragraph 20 of your first witness statement on page 4, you say in the second line of paragraph 20, you say, and there was even talk of a deficiency notice being placed on the building as a result. That was as a result of the system being inoperative, the existing system. But would you accept that the email I just showed you, which you were copied into, shows that PSB were aware, in fact, that a deficiency notice had been placed on the building?
Yes.
Was PSB ever sent a copy of that deficiency notice?
No, because we weren't involved in the project.
Did the fact of that deficiency notice affect the advice that PSB gave about the design of the system in any way?
No.
Were you also aware that there had been a fire at Grenfell Tower in April 2010 in which the existing smoke control automatic opening vents had failed to operate?
No,
So you were never aware that there was a fire where smoke had leaked from the system's extraction shafts into other floors of the tower?
no.
Had you known that, had you been told that, would that have affected the design advice that you gave about improving the existing system?
Only in so much as to tell them they should have been maintaining it and making sure it operated correctly. Other than that, no.
Okay. Now, just stepping back and just thinking about the regulatory requirements which apply to the design of the refurbished smoke control system at Grenfell Tower, can you just explain which of the functional requirements in Schedule 1 of the building regulations you considered when designing the system at Grenfell Tower?
I don't think there's a straight answer to this, is there? Because, as I've already said, you could not put forward any system that would comply with any of the guidance. It was impossible. So there was no system type you could put in there. So therefore, we, as designers, looked at it from a different direction and said, well, the spirit of the standard is to protect the stair. Can we come up with an alternative design that will protect the stair that doesn't comply with anything? And that was our starting point.
Yes, I see. And when you say there, you said to yourselves, well, the spirit of the standard is to protect the stair. What standard are you referring to there that protects the stair?
That's with the approved document B, section 2.25.
I see. So you're saying that approved document B is talking about protection of the stair as the first objective, yes?
Yes.
So that was the consideration you applied?
Protecting the lobby as well as the stair. That was part of the due process that we adopted in the alternative proposal. So it wasn't just firefighting, which implies the stair. It also is to protect the lobby. But you couldn't do it in a way that met any of the standards.
I see. So just to be clear, did you have requirement B1 on means of escape? The building shall be designed so that there's appropriate means of escape in case of fire from the building to a place of safety. That's functional requirement B1. Did you have that in mind when you were giving your design advice?
Yes, as I just said, 2.25.
And B5, functional requirement B5, the building should be designed and constructed so as to provide reasonable facilities to assist firefighters in the protection of life. Did you have that in mind when you were giving your design advice?
Yes, very much so, because the building didn't comply. It therefore should have had a separate firefighting lobby, which it didn't. Therefore, yes, that was very much in our mind, because the building did not comply.
What about functional requirement B3 on internal fire spread, including measures necessary to maintain compartmentation throughout the tower? Was that ever a consideration as part of your design work?
If my memory serves me well, I might be wrong here. B3 is not for flats. It's for buildings other than flats.
So you don't think functional requirement B...
Oh, no, I didn't say that. I'm just saying what B3 is relevant to.
So you thought that compartmentation in B3 was relevant to flats and what, not the whole building, yes? Compartmentation
is the primary requirement to control the spread of fire and smoke in a residential building. It's not the smoke control system. It is the actual compartmentation is the primary item that controls spread of fire and smoke. The smoke control system is only required in residential buildings to deal with a small quantity of smoke that comes out when people are making their escape, and then later on to protect the stair when the fire brigade are fighting the fire. But compartmentation is the primary requirement.
I see. But just going back to my question, did you think about functional requirement B3 at any stage when you were designing the smoke control system in terms of the internal fire spread?
No.
Now, I want to ask you some questions now about the Max Forden brief and initial designs. If we could go to paragraph 21 of your first witness statement on page 4. Here you tell us, you say Max Fordham's initial proposals for the smoke control system essentially involved stripping out the controls and equipment used in the pre-existing system and installing a new system which reused the ducts and shafts into the existing common lobbies. And you say their proposal, as set out in their employer's requirements document they produced, was to retain the broad principles of operation of the pre-existing system, but to turn it from a natural ventilation with mechanical boost system into a fully mechanized push-pull system. And we've already discussed what those two concepts meant, a natural ventilation with mechanical boost. Just to be clear, what do you mean by a fully mechanized push-pull system?
When it operated automatically.
I see. So you'd still be having inlet air through the south shaft and up into the lobby and extract coming out through the north, but this time with mechanical assistance from the outset, yes?
Yes, and would operate automatically on detection rather than manually by the fire brigade.
Yes, I understand. Now, if we can go to paragraph 27 of your second witness statement on page 5. You say this, you say, the push-pull system proposed by Max Fordham is a type of smoke control system usually employed when the travel distance in the escape corridor leading to the stairwell is greater than that specified in the ADB or BS 9991. Such systems are designed to provide smoke dilution on the escape route, reducing the levels of smoke toxicity and visibility to acceptable levels. This is achieved by introducing clean, fresh air through a mechanical inlet air shaft at low level, local to the stair door within the corridor. An extract shaft is located at the furthest end of the corridor, extracting diluted air smoke at a volumetric rate equivalent to the fresh air inlet. Now, if we could just go back to the start of that paragraph and just have that up on the page. Now, at the time when you were working on the system design for Grenfell Tower, were you aware what the travel distances were in the lobbies between the flat doors and the stair door?
Roughly, yes, by measuring off the drawing we were issued with.
So you say roughly, yes. What did you understand those travel distances to be?
In a region of 9.5 meters at the worst point.
And you say you understood that from measuring off the drawings you were issued with. Did you actually do that exercise of measuring those travel distances at the time?
Yes.
Were you aware that the maximum travel distance in the lobbies at Grenfell Tower exceeded the 7.5 metre threshold for an extended travel distance specified in approved document B on fire safety?
By measuring 9.5, yes.
Yes, and we've seen this before with another witness, but just for the transcript, table 1 of approved document B makes clear that the maximum travel distance in common areas of blocks of flats is 7.5 metres. And can we also agree that the maximum travel distance in BS 9991, you mentioned that standard in your statement, is also 7.5 metres. And after that, it's considered to be an extended travel distance.
Correct.
Let's just briefly look at that. It's BSI 50621. This is, that says 8414. Sorry, BSI 50621. Yes, this is BS 9991 2011, Fire Safety and the Design, Management and Use of Residential Buildings Code of Practice. And if we look at figure 6 on page 36, and in the bottom, you can see the 7.5 metres is shown in that bottom diagram. Do you see that?
Yes.
And it makes clear, for example, if we look on at page 160, if we look right at the bottom of that page under extended corridors, it says where the design of a block is such that the travel distances exceed those shown in figure 6 and figure 7, a fire engineered mechanical smoke ventilation system, MSVS, may be provided to compensate for the extended travel distance. The primary objective for this type of system is to maintain tenable conditions within the extended corridor and the associated staircase enclosure for means of escape purposes. And then information about tenability criteria can be found, and it gives the reference. So for the purposes of BS 991, anything above 7.5 metres is extended, and that guidance we can see is provided about needing to maintain tenable conditions in the corridor and the stairs. Now, if we look at Dr. Lane's report at BLAS 5037, page 25, if we could zoom in on figure 15B there, this is her measurement in her phase 1 report of the travel distances. You can see the Grenfell lobby in the middle with all the flats around the outside. And can you see that from flat 4, she's measured 10.3 metres. Do you see that?
Yes.
Now, just to be clear, the BRE in their report following their survey at the tower, they measured the same distance at 9.3, so slightly less than that. And you've said you thought it was around 9.5 in the worst part, is that right?
Correct.
But whether or not it's 9.3, 9.5 or 10.3, that was an extended travel distance, wasn't it, compared with the 7.5 maximum in ADB and BS 991?
It was.
Now, just going back to the way you described the Max Fordham system, going back to paragraph 27 of your second statement, page 5. You say in the first part of paragraph 27, the push-pull system proposed is a type of smoke control system usually employed when the travel distance in the escape corridor leading to the stairwell is greater than that specified in those 2 pieces of guidance.
That's correct.
Now, do you agree that the way you've described that Max Fordham proposed system suggests that this extended travel distance wasn't a complication you were facing at Grenfell Tower?
No, that complication was there. The fact it's impossible to put the push-pull system in to compensate for it. It's impossible to put it in. So the dilemma was there. The fact we could not design a system that complied with any of the guidance whatsoever was a problem.
I see. So you're saying you were fully aware that there were extended travel distances at the time you were carrying out your design work, yes?
That's correct.
Thank you. Now, if we go to paragraph 23 of your first witness statement now, page 5. Now, in this paragraph and some that follow, you are explaining your concerns about the Max Fordham proposal for a push-pull system. And you say this, you say, when I looked at these proposals, however, I could see that could lead to problems with excessive pressure drop due to the high induct velocity within the existing builder's work shafts, which could result in inadequate flow being achieved through the shafts. And then you go on and say, as a result, I developed an alternative proposal, which still reused the existing ducts and shafts as per the employer's requirements, but which could achieve the functional objectives set out in the relevant guidance in place at the time. Now, just taking that explanation in stages, firstly, can you just explain to us why would air entering the existing builder's shafts potentially quickly result in an excessive drop in pressure?
Not drop, an increase.
I see. Can you explain your concern then?
You're trying to, it's a bit like the old quart into a pint pot. You're trying to push too much air through a small hole. And it would lead to large pressure drops within the system, which are difficult to keep a balance of. And in addition to that, the wall openings into the lobby would have had velocity jets somewhere in the region of 20 to 25 meters a second, which if there was a fire in an apartment in, say, the south end of the building, then when the fire brigade were fighting a fire, that jet would probably push smoke into the stairwell. So we could not maintain the stairwell clear of smoke. So the push-pull system was just impossible to put in to work in status because of the restrictions of size.
Yes, I see. So just to be absolutely clear, you say, first of all, it's a bit like the old quart into a pint pot. You're trying to push too much air through a small hole, and it would lead to large pressure drops within the system, which are difficult to keep a balance of. Can you just explain how that process occurs?
Well, as you're trying to force a large volume of air through a small duct, it just increases the pressure drop within that shaft. And all performance characteristics for ventilation in ducts is based upon laminar flow, not turbulent flow, and it's on reasonable velocities, not high velocities. These would be high velocities. That would lead to excess pressure differentials, pressure drops that we would normally work to. We would normally work about 8 meters a second in duct maximum velocity, and this was far in excess of that. But it was also the velocity jetting through the wall opening was a problem. That would also create a big pressure.
Yes, I see. So you've got these large pressure drops within the system, which you say are difficult to balance out. And then you say, in addition to that, the wall openings into the lobby would have had velocity jets somewhere in the region of 20 to 25 meters a second, which if there was a fire in an apartment, would mean that you couldn't maintain the stairwell clear of smoke. Again, can you just explain slowly what the mechanism is for that to happen?
If you would bring up the sketch you just had from Lane's report of the floor plan.
Yes, so that is...
That's the one.
Yeah.
If we look at flat 3,
yeah,
if that was the flat that was on fire, and then you have the little duct in the middle alongside it, which is the fresh air input duct. And then you have the stair door will be open when the fire brigade come to fight the fire. They would then open flat 3 door to fight the fire. The smoke that comes out from that flat door will be picked up by the velocity jet from that low level grill, potentially, and pushed into the stair because the doors are. So that would then be a failure of the system.
And was that a particular feature of the layout of that lobby and the configuration of that south vent? So that south vent isn't marked, but I think for the panel's consideration, it's a series of very small little lines between the 4.7 meters and the 2.8 meters. That's where the south vents are. And then the north vents are up from that, and you see some similar little dotted lines. So was it a particular feature of the configuration of this lobby that led to that problem?
No, it's the size of the ducts.
I see.
It's the size of it's the velocity is a problem for that particular application. In smoke vent terms, we generally work to a maximum inlet velocity of 5 meters a second. Okay, and there are reasons for that, but that's what we work to. 20 to 25 is a lot more than 5.
Yes, I see. So you've basically got kind of serious velocities going on across this lobby, which potentially could be dangerous in terms of smoke being pushed towards the stair.
Yes, smoke contamination of the stair.
Yeah, I understand. Now, if we go back to your statement and we look at paragraph 28 and 29 of your second witness statement on page 5. So it's page 6, yes. You tell us in 28, I knew from experience that there would be a number of problems with the proposed use of a push-pull system in Grenfell Tower. And you say, as well as the issues it raised in paragraph 23 of my first statement, I was also aware that the lobby layout at Grenfell Tower was not a typical corridor arrangement. The 2 shafts were located on either side of the lobby, but there were additional areas coming off the main lobby area, which provided access to the flats in each corner of the tower. One shaft had a grille at low level, that's the south side, and the other had a grille at high level, the north side. The location of the door from the lobby to the stair was also an issue, as it was not positioned at the end of a corridor. I recognise that the specific orientation of the lobby and the position of the shafts and door to the stair in Grenfell Tower meant that it would not be possible to adequately mitigate the risk that smoke would enter the stair using a push-pull system. Given the size of the lobby and the position of the shafts, there would also be dead spot areas in the lobby where there would be no airflow and therefore no mixing of air and smoke to create dilution. Now, if we just go back to that diagram from Dr. Lane again, while we're looking at this. Now, is it right that one of your concerns was that given the unusual shape of the lobby, we can see this I shape where you've got kind of corridors going off to the corners, top and bottom, with the vents positioned in the middle of that I, yes? Mm-hmm. It's one of your concerns that with a push-pull system where the smoke is going across that lobby, that might not mitigate the risk that smoke would enter the stair, yes?
Yes. And
you've also expressed concern that there might be dead spots in the system at the branches of the lobby where there would be no airflow. So is that, say, at the corners of, say, flat 5 and flat 4, flat 6, flat 1, and then at the bottom left-hand corner and the bottom right-hand corner, you've got these little corridors branching off. You're concerned that there could be dead spots with no mixing of air in those places. Is that correct?
That's correct, yes. The principle of a push-pull system is usually air flowing through a straight tube, i.e. a corridor. And it travels through that straight tube with a velocity, and it mixes air with smoke as it travels, and it reduces the level of toxicity and obscuration within that corridor because it's mixing and pulling out. In that particular arrangement, if we look at, say, flat 4, the doorway there, smoke could stay in that section of corridor and not be pulled in to the system. It would just stay there.
Yes, I understand. And did you have any other concerns about any other aspect of Max Fordham's proposals?
The main concern I had throughout any of the system types was the size of the shafts, and that's. But are you talking specifically about push-pull?
Yes. Is it fair to say that those are the main concerns?
They are the main concerns. One, we couldn't guarantee not contaminating the stair. We could not guarantee that. And we could not use a push-pull system in the normal sense, i.e. a straight corridor.
Yes, I understand. Mr. Chairman, I think that's a good moment for our morning break.
Yes, Strange, thank you. So do I. I was going to suggest it anyway. Well, Mr. Mahoney, I said we'd have a break during the course of the morning, and this is a good time to have it. So we'll stop now. We'll resume, please, at 25 to 12. And I must ask you, please, not to talk to anyone about your evidence or anything relating to it over the break. All right?
Thank you.
Thank you. We'll look forward to seeing you then in 15 minutes or a little more. Thank you very much.
Okay.
Thank you, Ms. Grange. 25 to 12.
Thank you.
Right, we're ready to carry on, so I'm going to begin by ensuring that we have contact with Miss Grange. Hello, Miss Grange, we can see you. Can you see and hear us?
Yes, I can. Thank you.
Good. Thank you very much. And then we better make contact with Mr. Mahoney. Mr. Mahoney, are you there again?
Yes, I am. Thank you, Chairman.
Good, thank you very much. And you're ready to go on, I hope.
Yes, indeed.
Good, thank you very much. Yes, Miss Grange, then when you're ready.
Yes, thank you. If we can just look back at paragraph 23 of your second statement, I think it is. No, your first witness statement, sorry, page 5, paragraph 23. You say in that last sentence, as a result, I developed an alternative proposal which still reused the existing duct and shaft as per the employer's requirements, but which could achieve the functional objectives set out in the relevant guidance in place at the time. Now, just concentrating
Right,
on...
Ms. Grange, I'm just going to interrupt you. If that was the end of paragraph 25, I don't think Mr. Mahoney could see it.
No,
Sorry.
23.
23, I
Oh, I'm
said.
sorry, my fault then. Right.
So you're referring there to, but which could achieve the functional objectives set out in the relevant guidance in place at the time. Now, can we just be clear, what was that relevant guidance from which you were taking those functional objectives?
That we had to provide ventilation to the lobby, to provide ventilation of any smoke that may reach that lobby when people were making an escape, and to provide an open door condition for the firefighters when they were fighting the fire. So that was the B1 and B5 requirements.
I see. So are you saying that could achieve the functional objectives set out in the relevant guidance? Are you saying those are the functional objectives of the building regulations as set out in, for example, approved document B? Is that what you're referring to there?
Yes.
So are you referring to any other pieces of relevant guidance in which there are functional objectives set out in that paragraph?
No.
So you're not referring to functional objectives that may have been set out, for example, in BSEN 12101 Part 6 on pressure differential systems?
It was impossible to put such a system in. Anyone knows anything about smoke control will know it's impossible to put a pressure differential system in that's fully compliant in a block of flats. So no, it wouldn't be anything to do with that particular standard, because that is impossible to apply.
And just to be absolutely clear about what you thought those functional objectives were. So in terms of the stair, what were your functional objectives?
To keep it relatively clear of smoke.
When you say relatively clear of smoke,
That's the wording from the standards.
which standards are you referring to there?
I think that's in 9991 and ADB.
So you're keeping the stair relatively clear of smoke. What about the lobby?
To put ventilation in there that will deal with some smoke which may enter the lobby when people are escaping from their flat. From the fire apartment, sorry.
And again, where are you getting that requirement from? Some smoke which may enter the lobby.
2.25 of ADB.
2.25 of ADB, yes. And did it include protection of the stair for firefighting operations?
Yes, I've already said that.
And protection of the lobby for firefighting operations?
Yes.
Were those functional objectives, so what you've just said, that we're trying to keep the stair relatively clear of smoke, etc., were those functional objectives ever set out by you or anyone else at PSB in a document?
No, it wasn't necessary, as I said before, because the project didn't go ahead based on the design. It went forward on the betterment on the ventilation rate.
So why was it not necessary to set out the functional requirements?
Because the design was not accepted.
And when you say because the design was not accepted, which design are you saying was not accepted?
The PSB design. We put forward a design proposal to fulfill those functions. Max Fordham and partners decided that they couldn't go with a system that didn't comply with anything. that they could refer to, so they went forward on a betterment. They used the ventilation rate that we gave them to prove the betterment. So it wasn't a design that went forward, it was a betterment that went forward.
I see. And when was that agreed with Max Fordham?
That wasn't, when you say agreed with Max Fordham agreed it with building control.
I see. And what, you were just told that that's what happened?
Yes, when we tendered the job, a document was placed before us which said that's what was the case, and that document was adopted and placed in our technical submission.
Right, I see. Now, if we go to paragraph 32 of your first statement, page 7. In this part of your statement, you've listed a number of different types of smoke control system that can be installed in high-rise buildings. And just to quickly run through them, there's the natural ventilation system, which we've discussed.
Yes.
And is it right that the main problem with Grenfell Tower was the size of the shafts, which were not large enough to achieve a high enough airflow rate?
That's correct.
Did you ever do a calculation to confirm that?
To confirm what? The size?
To confirm that the shafts were not large enough to achieve a high enough airflow rate with a natural ventilation system. Did you ever do a calculation?
It doesn't have a calculation. It's based on a size, a dimension, cross-sectional area, 1.5 square metre shaft. It's not based on a calculation.
I see.
So if you went to prove that system on the day of commissioning, for example, you wouldn't measure the shaft. You wouldn't do a calculation.
Right. And then we have a natural ventilation with mechanical boost. Again, we've discussed that before.
Yes.
You say at paragraph 32.2, it's on the page here, that the big problem with this type of system, you say in the last sentence, however, even with the addition of fans, I did not think that the existing shafts were large enough to allow air and smoke to flow at an effective rate. Yes?
Yes.
What do you mean there by an effective rate of airflow?
To meet the design requirement.
And when you say,
where's that statement?
So it's the end of 32.2. It's in the middle of that page. There's a sentence that says, again, however, even with the addition of fans, I did not think that the existing shafts were large enough to allow air and smoke to flow at an effective rate.
Right, they weren't large enough for natural ventilation to produce the desired requirement. And even with the boost fan, that was limited by the size of the fan, not the duct.
I see. So you concluded that simply because of the size of the fan, that wasn't a viable option, yes?
It was certainly not a viable option, no.
And then there's the push-pull system, which we've already discussed, and you've explained what your concerns with about that.
Yes.
And then going over the page, you talk about a pressurization system, which is another type of mechanical smoke control system.
Yep.
And a pressurization system, is this right, would use fans to move air into the stairwell itself, creating a higher pressure in the stairwell, and so preventing smoke moving into the stairwell.
Mm-hmm.
Is that right?
Yes.
And was the main problem with that, in your view, that that would require the stair to be well sealed so that this positive pressure was maintained?
No. A pressure differential system to BSEN 1210-6 is very express in its requirements and its layout. And it is impossible to install that compliance system within Grenfell Tower, or for that matter, any high-rise block of flats. You just simply can't do it.
Yes, I understand that, but it's right, isn't it, that British standard refers to two types of pressure differential system, and one of them is the pressurization of the stairs. Yes.
Yes and no. It's far more in detail than that. You pressurize the stair, you pressurize the firefighting lobby, and you pressurize the firefighting lift, and you must have an exhaust path within each dwelling.
I see. And was that considered and discounted for Grenfell Tower?
It's discounted on any block of flats, never alone Grenfell Tower. Grenfell Tower has just made it even more difficult because of the restriction of the employee's requirements.
Yes, I see. If we go to an email PSB 6025. There's an email from Mr. McGregor to you on the 2nd of May 2014. He says in the first paragraph of this email, Hugh, this is one I looked at some time ago, and we discounted changing the system to pressurization system as it would be much too difficult. Getting the ducts in, leakage paths would be a nightmare. Do you recall this email?
Yes.
And can you just help us, what pressurization system had you discounted at that stage as being too difficult?
Any pressurization system.
So when he says getting the ducts in, leakage paths would be a nightmare, what specifically is he referring to in terms of getting ducts in and leakage paths?
Right. To comply with the requirements of that standard, you would have to put a large air delivery duct to serve the stair, which no slab openings are available for. You'd have to put a very large duct in to deliver the air to the lobbies, and there was no openings in the slabs to accommodate that. You'd also have to have a much smaller duct, but a duct nonetheless running through the height of the building for the firefighting lift, and the openings for that didn't exist. And in every flat, because you didn't have two opposing walls to put automatic opening window vents in, which I'm sure the tenants wouldn't have wanted anyway, you've had to put a very large 1.6 square metre minimum cross-sectional area duct in every flat running through the building.
Right.
So if they've got 6 flats per floor, that's 6 very large ducts running through the height of the building. So they just did not exist, so therefore you couldn't put it in.
Right. Now, Mr. McGregor also continues in that same paragraph. We could have the email back up on the screen. He carries on, he says, in the third line down of that first paragraph, use existing push-pull system, uprating what they have got is the easiest solution by a long way. Do you see that?
Yeah.
Now, do we take it that you didn't agree with that assessment?
I totally disagreed with that assessment.
Sorry, can you say that again?
I totally disagreed with that assessment.
I see. So did you and Mr. McGregor disagree about whether the push-pull system was viable?
Initially, until we discussed it, then he agreed.
I see. Now, just moving on to your developing a design for a depressurization system. Can we look at paragraph 24 of your first?
If you read my wording, it's a mechanical extract ventilation system which would depressurize the lobby. It's not a depressurization system per se.
Well, let's just look at paragraph 24 of your first witness statement on page 5, because I want to look at how you've described this system in your statements. You say in the first line, the design I developed was for a depressurization system.
Mm-hmm.
In other words, a system which achieved smoke control using depressurization principles achieved by mechanical extraction. Depressurization systems are one of the most common types of smoke control system used in buildings in the UK. They are designed to deliver protection to the protected space, in this case, the stairwell, by extracting air and combustion products from the common lobby to create a pressure differential and opposing airflows between the stairwell and the common lobby. So you were picking me up earlier on the fact that I described what you'd said as designing a depressurization system. Can we agree that that is what you have said in the first line of this paragraph?
Yes, by using mechanical extraction. Any system in a lobby, whether it's natural or mechanical, depressurizes the lobby. That's how it fulfills its function. So whether it's got a fan or it's just natural, it depressurizes the lobby.
Yes, I understand. And just looking at that paragraph, and we'll come on to some more explanation that you give of this in a moment. You say in the middle, 4 lines down, that they are designed to deliver protection to the protected space, in this case, the stairwell. Now, can we just be crystal clear? You are saying there that you designed it to give protection to the protected space, i.e. the stairwell, does that mean that it was only the stairwell that was the protected space in accordance with this system?
Protection, yes, but it would also deal with any smoke that entered the lobby with the before the door closed again.
So just to be clear, even though you're saying here they're designed to deliver protection to the protected space, in this case the stairwell, you're saying that your design also delivered protection to the lobby, yes?
Not full protection, and no system does offer full protection. Even if it's natural, smoke will enter the lobby and will be diluted by whatever ventilation system is in there, but it doesn't protect it.
So was it designed to deliver some protection to the lobby? Is that a fair way of putting it?
All systems are designed that way, whether it's natural or mechanical.
Yes.
If you have a natural shaft, that's how it fulfills its function. They're not smoke extract systems. They're smoke control systems. They stop the smoke going where you don't want it to go. We can't stop it coming into the lobby. As it says in the approved document B, that's a natural requirement or a natural occurrence because people are evacuating a flat that's on fire and some smoke may come with them. Okay, so that's why you ventilate the lobby, because some smoke may come. The smoke is already in the lobby. What we then have to do is stop it getting into the stair.
Yes, I understand. Now, if we look at your second, that was your first witness statement and how you described the system there. If we look at your second witness statement at page 7, starting at paragraph 34, you describe the system in this second statement as a mechanical extract depressurization system.
Mm-hmm.
Principally works by extracting air and smoke from the lobby so that when the door between the lobby and the stairwell is opened, an airflow is created from the stair to the lobby, which would limit smoke ingress into the stair.
That's correct.
So is it right that the primary purpose of the system is not to extract the smoke from the lobby, but it's to create an airflow between the stair and the lobby when the stair door is opened? Is that correct?
I'll say it again. It's not a smoke extract system. It's a smoke control system.
Thank you. Now, there's a helpful illustration of this in Dr. Lane's phase 2 report. If we could go to BLARP 2, 5035 at page 260. So if we could blow up that diagram. Here, what Dr. Lane has done in simple terms is tried to translate the design intent of the PSB system into this diagrammatic form in simple terms, yes?
This is a later design. Which design are we talking about? Originally, everything was extracted from the top of the building. The two shafts were joined together in the rooftop plant room with one extract fan set. Yes. This is a much later development.
I see. So I think this is the design as it was finally intended to be. Is that correct?
That's correct, but it's not our design.
When you say it's not your design, why do you say that?
Our design was to connect two shafts together, the south and north side, in the rooftop plant room with a single fan set. The design evolved through the course of the contract by other parties.
I see. So are you saying it wasn't part of your design intent for the smoke to be extracted downwards, as we can see on the bottom left-hand side of that drawing?
Initially, no.
But did it become part of your design that it was extracting downwards? We can see the smoke path and through the ductwork at the lower levels and then out to the outside.
It became incorporated by the instruction of others.
It sounds from what you're saying like you were not happy with that instruction by others. Is that the case?
Well, not that I'm not happy with it. My preference would have been the original design. It was a much cleaner, simpler design than what then evolved during the course of the construction work on site.
But were you so unhappy with this revised design that you actually spelt that out to other professionals on the project?
No, it would still work, but it's not as clean a design as I'd proposed.
I see. So you didn't express any concerns about this final design?
Not overly, no.
No. So this final design, as we can see, it's extracting down through the south shaft and through some new duct work at lower levels and out.
Mm-hmm.
And at the same time, it's extracting from the north vents, the north side lobby vents, and then up and out at roof level. Is that correct?
Correct.
Now, we've got a diagram at showing on a floor plan how this was intended to work. If we can go to BLARP 2, 5035 at 261. So again, just in simple terms, what Dr. Lane has done here is give an indication of how, and this is the final design, how the final design was intended to work. So can you just explain for the panel what we can see here? First of all, we can see some red arrows extracting at south and north. Is that correct?
That's correct.
And so what was the intention of exhausting smoke at both sides?
This particular diagram shows the firefighting phase, not the means of escape phase. The design proposal was that in extracting air from all 4 shafts, we would create a velocity across that open door that would stop any smoke that was in the lobby at that stage entering the stair. And then once the fire door was actually open for the fire brigade to fight the fire, it would still keep the stair reasonably clear of smoke, even with that fire door open and, in fact, a broken window in a fire flat.
Yes, so let's just take this in stages. Assume wasn't the main design intent or the design condition for the flat door to be shut?
That's not what's shown in that diagram.
Well, where are you seeing the flat door open?
It shows all the doors are open.
Okay, well, assume for the moment that all the doors around the lobby are closed, yes?
Right.
Was the primary design of the system to ensure that if the stair door was opened, there would be a velocity across that stair door of 2 meters per second, which would keep any smoke that had entered the lobby out of the stair. Is that correct?
That is correct.
Yeah.
But the main criteria is extracting 3 cubic meters a second.
When you say the main criteria is extracting 3 cubic meters per second.
If we go back to the original design concept that we put forward, we told Max Forden we would want to extract from that lobby 3 cubic meters per second. They asked, where did you get that from so we can benchmark it in some way? And we said, right, it's based on an open door velocity of 2 meters a second. And that came from BSEM 121.6. But the key criteria was 3 cubic meters a second extraction rate.
And is that 3, precisely where would you measure that extraction rate when the system's working? At the vents in the lobby?
You can measure it at that door because the velocity will give you the volume flow.
I see. So what you're saying is the velocity of air across the door will tell you what the volume flow is across that door, i.e. across the stair door.
That is correct.
Yeah. So you're saying the volume, just to be clear, you're saying the volume rate at the door was 3 cubic meters per second, yes?
Yes.
What about the extract rate at the vents where the red arrows are?
They would total up to 3 cubic meters a second, all 4, added the 4 together.
I see. And you said before that this diagram, you said in your own words, shows the firefighting phase. Why do you say that? Because
it's showing the doors open. In the means of escape phase, back to the ADB, it tells you that when someone escapes from the flat that's on fire, it is possible that some smoke may come with them purely because they're escaping. So take whichever door you want, opens, the people in that flat evacuate, some smoke may come with them, may not, and then the door closes afterwards because it should be a self-closing door. And at that level of smoke at that time is what the ventilation system should deal with all the doors closed, okay, as in B1. So there would be a minus 25 PA ventilation rate in that particular lobby. So that gives you your B1 requirement. Once the fire brigade arrive, they open the stair door and the flat door. And at that time, we've got to go to B5, and the system would go to a much higher volumetric flow rate to give you the 3. And not forgetting, when the people first go to make their escape, there is no ventilation whatsoever. It's only if smoke enters and triggers the smoke detector in the lobby. Until that happens, there's no ventilation.
Yes, and just to be clear, can you just explain exactly what would happen when the stair doors was open, but all other doors remain closed?
The fan system would ramp up to full duty because there's a pressure measuring device, pressure differential measuring device between the stair and the lobby, and it would show you can't maintain the minus 25 PA tick over level, and it would put the fans to a high speed.
Yes. So is this right, that the fans would be at low speed,
Yes.
but once that door was open and that pressure differential changed,
Yes.
the fans would then move to high speed, yes?
Yes.
And there wasn't a system whereby the fans could then ramp up again, was there, if more doors were opened?
No, there's no boost facility, no.
No. Now, can you just explain in your own words why this system, this pressure differential system, addressed the problem of the existing shafts being too small?
Because we have 4 shafts that we're using, as opposed to 1 or 2, we can use the 4 to get far more air through.
Yes, I see. So instead of one set of shafts putting in inlet air and the other one sucking out air, what you're saying is under this system, all 4 of those shafts are extracting air, yes?
That's correct. So the velocity, induct velocity will be lower. If it's a push-pull system, for example, you have 100% duty going in, 100% duty going out. With an extract system, you have 50% across each side.
Yes, I understand. Is it common to have this kind of depressurization or pressure differential system like this in a residential high-rise building?
Like this? No.
Yeah.
It's the employee's requirements that dictated this. No. If it was a new build, it wouldn't go in that way. There'd be a single duct with a single extract grill.
Are you aware of any other building that you've worked on which has a smoke control system? Sorry, any other high-rise residential building that has a smoke control system like this one?
Absolutely not. As I said, it was an alternative solution to try and reach the spirit of the standard because we couldn't achieve it in the standard way. It was impossible to put a standard system in because of the employer's requirements.
And what, in your opinion, would be the disadvantages of having this kind of system?
As long as the 3 cubic meters a second was achieved, it would protect equally to a standard system.
And when you say as long as those 3 cubic meters were achieved, it would protect equally to a standard system, what do you mean when you talk about a standard system there?
Standard shaft system, whether it be mechanical or natural.
So did you ask yourself the question at the time whether this system could provide equivalent performance to a standard mechanical or natural ventilation system?
Yes.
And do we see evidence of that equivalency analysis set out anywhere in the documents you provided?
No, because it wasn't necessary because the design didn't go forward.
Well, you keep saying it wasn't necessary because the design didn't go forward. I think you accept that this was the final design that we're looking at now. Yes?
No. What went forward was 3 cubic meters a second, 3.5 cubic meters a second. That's what went forward. How you delivered it is a different thing. The design is to get 3.5 cubic meters a second.
Did you ever ask yourself the question that with the system as it was designed and as it was intended to be delivered, so extracting down the south shaft, did you ever ask yourself the question whether that was providing an equivalent performance to a standard natural or mechanical system?
Yes, and I'm satisfied if it was CFD modelled, it would perform.
So you're saying that you're satisfied that had someone done a computational fluid dynamics model of this, it would have performed, yes?
Yes.
But just to be clear, no such CFD analysis was ever done, yes?
No, there was no instruction ever issued to carry out a CFD model.
Yes. Now, let's look in a little bit more detail at the actual proposals that PSB put forward. If we can go to the initial technical proposal, this is PSB 401233. We can see it's smoke ventilation technical proposal. It's issued for comment 22nd of April 2014, and then it says approved HMM. Is that you?
That's me.
Yeah. And were you the author of this document?
Yes.
And is it correct that this proposal was produced before PSB had been formally engaged to do anything on the project?
Yes.
And can you help us, to your knowledge, was this document ever provided to building control?
No, it wasn't.
If we look at section 1, the introduction on page 2, I just want to read what we see in the first 2 paragraphs. It says, having identified possible problems with the proposed push-pull system leading to excessive pressure drop due to the high induct velocity within the existing builder's work shafts, an alternative smoke control design solution is required. And then you say, after discussions, this report provides an alternative approach to designing a lobby smoke control system. Now, just to be clear, when you wrote this, what did you mean by an alternative smoke control solution or an alternative approach?
Well, it was following the discussions with Matt Smith at Max Fordham, where we pointed out it was impossible to put a appropriate system in that met all the standards and could be said to be compliant. Therefore, what we were proposing was to put forward a design that would protect the stair and ventilate the lobby, but it didn't follow any of the guidance. So it's an alternative approach.
Thank you. And then if we look at what you've said in the 3rd and 4th paragraphs there, you say these proposals will have to be firmed up and then submitted to the Building Control Authority for discussion and agreement as an acceptable alternative to originally proposed the push-pull system.
That's correct.
And you go on, the proposal is to design a depressurization system which will protect the stairwell by providing an airflow from the stairwell into the lobby when the stairwell lobby door is opened.
Yes.
You see that? Now, just to be clear, it's only talking there about protecting the stairwell, isn't it?
Yes.
It doesn't talk about protecting the lobby.
No.
Now, in simple terms, just pausing there, can you just explain whether and how your system addressed the problems of the layout of the lobby at Grenfell Tower, the I-shaped lobby, and dead spots, which you were concerned about with the push-pull system proposal?
It doesn't have to deal with that. No system has to deal with that because they're not smoke extract systems. They're smoke control systems. No system of compliant nature could deal with it either. So it's not something you consider. You can't do it.
So you've said that you were concerned about the push-pull system because of the way the lobby was configured, its geometric configuration and its relationship with the stairs, and the potential for dead spots along the corridors at the corners. Is what you're saying that the system you proposed here would have the same problems as that push-pull system in that regard?
It would have, but a push-pull system is designed not to have that problem. It's designed to reduce toxicity and obscuration levels. That's what it's designed for. The system I'm putting forward isn't designed to do that, and no system will remove those dead spots, whether it be natural or mechanical, because it's a dead spot. If a push-pull system had a straight corridor, as I suggested earlier, you deal with it because a dead spot doesn't exist because it's a straight corridor.
I see. So I think what you're saying is you didn't think that your design needed to concern itself with those dead spots.
It couldn't concern itself with, not that it didn't need to.
I see. And did you ever explain that in writing as part of the design documentation you produced?
No, we had discussions, as that document stated.
Did you ever explain to Max Fordham and others on the project that the system would have the same problem with dead spots and the same potential problems because of the geometrical shape of the lobbies as the push-pull system?
At what stage are we talking about? Because as I said before, we were not involved in the early stages of this project. We were asked for advice and we gave advice. So we weren't in contact with anybody other than Max Fordham's initially.
At any stage, did you explain to Max Fordham that those would be potential problems with the system that you were putting forward?
But they weren't potential problems. I don't understand the premise of your question.
I see. Is that because what you're saying is they weren't potential problems because although they would...
No. I'm not saying anything of the sort. If it was a natural vent system that was compliant, you would still have that dead spot. If you put a mechanical system in that was compliant, you would still have that dead spot.
I see. So it was a feature of whatever you were going to install there, you would have that.
That's right. But if you had a push-pull system, you're not supposed to have that.
And did you ever consider whether the particular layout of the lobbies at Grenfell Tower, including the travel distances, meant that actually those dead spots were something that needed to be grappled with as part of the design process?
They couldn't be. As I keep saying, if it's impossible to do something, it's impossible to do something. You can't do the impossible. So no.
I see. Now, just going back to the proposal, if we can just look at the title page again, we can see it says smoke ventilation technical proposal, stair depressurization systems.
Yes.
Can we just be absolutely clear? I think you've already confirmed this, but I just want to be crystal clear that unlike a simple mechanical extract system, its primary purpose was not to extract smoke from the lobby, but to prevent smoke entering the stair through the lobby door by maintaining an airflow across the door, the stairwell door, as a result of a pressure difference.
No. It's by removing 3 cubic meters a second from the lobby. That creates the that creates the velocity across the door. So depressurizing the lobby creates that protection.
I see. So are you saying that by extracting 3 cubic meters a second from the lobby, that was its primary purpose?
Yes.
I see. When we asked Mr. Hanson about this last week, the building control officer, he understood that it wasn't a depressurization system, but was what he called an extract system.
That's correct.
And he says that when there was a meeting about it, it was a meeting not about a pressurization system, it was about an extract system from the lobbies. He said the reality of a pressurization system in the existing building would be really quite difficult to do. So it seems that it's almost not practical. That wasn't the discussion at all. It was an extract system.
That's correct.
So if it was an extract system, why is it not described simply as an extract system in all of these documents? We
said mechanical extract to depressurize the lobby. That's what it does.
Yes, and that's right, isn't it? That as a consequence of extracting air from the lobby, you by definition create a pressure differential between the lobby and the stairs, yes?
That's correct.
Yes, thank you. Now, if we go back to the proposal, page 2, if we look at the 5th paragraph down now, it says this: the velocity across the open stairwell to lobby door should be sufficient to meet the requirements for a Class B system as outlined within BSEN 12101 Part 6, Smoke and Heat Control Systems, Part 6, Specification for Pressure Differential Systems, kits.
Mm-hmm.
You see that?
I see that.
Now, can you just explain to the panel briefly what is a Class B pressure differential system as outlined in that British standard?
A Class B system would pressurize the stair, would pressurize the lobby, would pressurize the firefighting lift. The stair would be 50 PA above ambient, the lobby 45, and the lift would be 50 PA, and there would have to be a defined air leakage path out of the fire flat. So air would be pumped into the building in large quantities, and then it would flow through the open door of the stair when the fire brigade were there, through the door of a flat and out through a smoke shaft or whatever the egress pass was out to the flat.
Yes, I understand. And it's right, isn't it, that the Class B system is for means of escape and firefighting, yes?
That's correct, yes. For a residential building, it's a Class A, and the difference is 0.75 metre a second across an open door. For Class B, obviously Class A doesn't do firefighting, Class B does both. So it's got a 2 metre a second open door velocity, and that being greater than 0.75 is the dominant number that you would design to.
Yes, and we can see that if we just look briefly at that in that British Standard. If we go to RBK 3045054 at page 17. We get a helpful table here setting out the classes of systems. And as you've just confirmed, a Class B system is for means of escape and firefighting.
That's correct.
Class A is for means of escape, defend in place, yes?
Yep.
Now, can we take it that from this, that you chose the Class B requirement, that's that velocity requirement, because the system needed to provide protection for both means of escape and during firefighting?
No. It was to justify the 3 cubic metres a second extraction rate. Back to the discussion with Max Fordham and partners, when we said how the system would work, they asked the question, what is the ventilation rate? We give them a ventilation rate, and they said, where does that come from? So we give that as a benchmark of where it came from.
Why did you choose that as your benchmark from that Class B system?
Because that is the ventilation rate we would put in a standard smoke shaft system using mechanical means of exhaust.
I see. So is it just a coincidence? Well, let's go back to your proposal. It can't have been a coincidence that it's also in that British Standard, because you're specifically referring to that British Standard in the proposal, yes?
Yes. When the industry developed these systems, that was one of the things we looked at, and that was the ventilation rate required to comply with both firefighting B5 and B1, and also in line with research that had been undertaken by the Building Research Establishment. And most companies will work on a delivery of 3 cubic metre a second extraction from the lobby as the ventilation rate required to protect the stair. But it came from that requirement of open door velocity. We knew that with that open door velocity, we can protect the stair. So that was where these systems developed from.
Yeah. And just going back to the proposal and the wording that we were just looking at. So PSB 40, yes. The velocity across the open stairwell to lobby door should be sufficient to meet the requirements for a Class B system as outlined in that standard. Where you say should be sufficient to meet that, did you mean that the velocity across the open stairwell door would meet that requirement, or was this just aspirational, hence the use of the word should?
It would meet it with just that door open. And if there was a stairwell vent, the stairwell vent open. As in the case of Grenfell, it was a permanent open vent.
So I think what you're saying is, if the stair door was open, but all other doors on the lobby were closed, it would meet that 2 metres per second, yeah?
That's correct. If other doors were then open, as in the fire door, it would still protect that stair by extracting 3 cubic meters a second from the lobby.
Yes, you don't ever say that second part of what you just said in any of the technical submissions, do you?
No, because this is a follow-on from conversations that we'd had.
Right.
We were just asked at this stage was to put some notes together to help Max Fordham, because we pointed out quite clearly this does not comply. And because it doesn't comply, you're going to have to go through to building control and say, is it okay to use this system? Because it's the only thing we can do. And they said, can you put some notes together? Don't go into any real detail at this stage because it may not be acceptable. Just give us some notes that we can discuss with them. And
yes, I see.
That's what this was.
And just to be clear, when you wrote these notes for the assistance of Max Fordham, were you intending to convey here that only the velocity across the open stairwell door would meet the requirements of that British standard, and that the system as a whole would not comply with that standard?
That was following up from the conversation that we'd had, yes.
Yes. So did you make it clear in conversations with Max Fordham that the system as a whole could not comply with the whole of that British standard?
Yes, because we discussed how the system would operate, and we were then asked to justify where we got our 3 cubic meters a second from. And that's where this reference to the Class B come from. So yes, that was all discussed.
At the bottom of that page, you say it's proposed to use all 4 of the Builders Works shafts as part of the smoke control system, mechanical extract, which will result in a much reduced average in-duct velocity of 5 meters per second.
Yes.
Can you just explain what you mean there by an average in-duct velocity?
Well, if you take the total volumetric flow rate and divide it by the area of duct available, it will give you the average in-duct velocity.
I see. So that's the average velocity through each of the 4 different ducts. Is that right?
As an average, yes. It will not. You can't balance those, so it won't be. It's not precise, but yes.
Yeah.
And again, you can see there we clearly state it's mechanical extract in that last paragraph.
And then if we go on through this document, page 3, we see some calculations, including your calculations of airflow through an open door. Yes. Can you just explain in simple terms what these calculations are showing?
Right. If you have a volumetric flow rate, it's cubic meters per second. To find out what that number is, you multiply area, which is the area of the opening, the door, by the velocity that you require, which is 2 meters a second. So square meters times meters per second gives you cubic meters a second. So multiply the area of the door by a velocity gives you 3.2.
3.2. And then you say you've added 50% for unforeseen losses.
Yes.
This will cover unidentified fabric losses. So that's like leakage within the ducts, yeah, or leakage within the shafts.
And dampers.
And dampers. And why do you add 50% for that?
It's just a notional number that's put in that British standard. At this stage, we hadn't gone into any detailed design work. As it says on the other page, it will need to be developed on and detailed work we put into it. So at this stage, we were just saying it's not just 3.2 we need, because to deliver that 3.2, we need a lot more air because we're going to lose it in the system.
Yes, I see. And then you've got a section underneath for fabric losses.
Mm-hmm.
I think you're just explaining your 50%. Is that right there?
Yes.
And then you've got underneath that area for pressure relief at the bottom of that page.
Mm-hmm.
Again, can you just explain in simple terms? I think what you're saying here is that by extracting the air from the lobby, you will by definition create a force across the closed door to the stair.
Which would be too great to open the door.
And so this is where your fan speed is important, that you need to make sure that you've got pressure switches that are able to ensure that the fan is at low speed until the doors are opened. And then when the stair doors opened, the fan goes up to high speed to keep that velocity. Is that right?
That's correct, yes.
Yeah. And then we can see on page 4 a list of components. We just go over the page. You've just outlined there a draft list of components. And then there's brief mention of the environmental system at the bottom of that page. Now, if we can now go to the first version of the PSB technical submission for the smoke control system. This is at PSB 50207. We can see from the revision history, it's revision 0. It's got you as the author, HMM again, and it's dated the 12th of November 2014, yes? Now, again, did you write this technical submission?
I did.
And is it right, and I think you explained this in your first witness statement at paragraph 36, that you produced all the subsequent revisions of the technical submission except for the final version, revision 6, which was produced just after you left PSB.
That's correct.
Now, to what extent did any other staff at PSB input into the design decisions that are shown in this technical submission?
None.
And what was the purpose of this technical submission? Can you help us?
This was put together to show what the components would be.
When you say put together to show what the components would be, it's called a technical submission. Does that mean that the entire purpose of this was simply to identify the components?
Yes.
So it wasn't supposed to be acting as a full specification for the smoke control system?
What do you mean by full specification?
Well, identifying the design intent, the objectives of it, and then the facets of the system.
There's a brief introduction to the design intent, which is to achieve the ventilation rate. I think there'll be then a reference, can't remember now, to the base document that this was based upon, i.e. what influenced this document, and then the components we would use to put a system together.
And is it correct, and we'll go to the text of it in a moment, that this submission was prepared for JS Wright, who were by this time receiving PSB's proposals? Is that correct?
It may be, I really can't remember.
And if we look at the very bottom of page 3 and on to page 4, this document has 2 different phases of proposal that it's dealing with. Is it right in general terms that phase 1 was a temporary solution for the existing system and phase 2 was the permanent design of the refurbished system?
Going back to your previous question, yes, this was produced for JS Wright. Now I'm reading this, I can see that was the case.
Yeah.
Phase 1, we were asked to consider bringing the existing natural vent system to a working status because it was not working, and to implement that as quickly as possible. And then that would then be followed by converting it to a mechanical system.
Yes, I understand. And if we go over the page, I think we can see phase 2 is dealt with.
Yes.
Phase 2 then is the mechanical smoke extract.
Mm-hmm.
At a predetermined date, phase 2 will be to implement to convert the system into a fully mechanical extract system with a new smoke extract run, etc. Mm-hmm. Now, let's actually look now at the second version of this proposal, JSW 403526. We can see this one's dated the 1st of December 2014. And again, you were the author of this proposal, yes?
Yes.
And if we go to page 3 and look at paragraph 1.1.2, we look at the bottom, we see this about the design intent. It says the final smoke control system has been designed to provide the existing stairwell with protection from the ingress of smoke from a fire within a dwelling by means of a mechanical extract system. The system has been designed to provide an average open door velocity across an open lobby stairwell door of 2 meters per second. This velocity is in accordance with the recommendation for a Class B pressure differential system as defined in that Code of Practice BS-EN 12101 Part 6.
That's correct.
And then in the next paragraph, it says this, I think that should mean it should be noted that as the system is designed to extract air from the lobby via the open stairwell door, the system is not designed to comply with all the requirements of the aforementioned Code of Practice. Now, just looking at that paragraph I just read out and the first part of it, what did you mean when you say that the system is designed to extract air from the lobby via the open stairwell door?
That we would be extracting from the lobby and the air would come in from the open stairwell door.
Yes, so the replacement air is coming from the open stairwell door, is that correct?
That's correct, yes.
I see. And in this version of the proposal, you've included the words then, the system is not designed to comply with all the requirements of the aforementioned code of practice. Why did you include that in this version of technical submission?
Around that time, there was a conversation with, I think with David Bradbury, but I can't be definitive on that. And there was reference to BSEN 12101-6, and comments were made. And I said, no, you're misunderstanding. It does not comply with that standard. It is only the 2 meters a second that we've taken from that standard that is applicable. The rest of the standard does not apply to this system other than the 100 newtons opening force to a door, because that's a general guidance and that's given in other standards as well. So I thought it was prudent to put that in there, that mistake made by one person would not be made by another.
Yes. So you wanted to make it clear to everyone reading the proposal that it didn't comply with all of the requirements for a pressure differential system as set out in that code of practice, yes?
Correct, yes.
Yeah. And then if we go to page 4, we can see some more details about how the system would be set up. So it says at the top of that page, if we look at the top half, the PLC control system. What does PLC stand for? Can you help?
Programmable logic.
Yeah. Programmable logic control system will have links to the new fire alarm system to provide an initiating signal. Once the signal is received, all the dampers, extract and inlet air in the smoke-affected lobby will open, and all dampers on other floors are to remain closed. And then you explain a human mechanical interface panel, HMI, will be located within the entrance area to provide the fire and rescue service with a central override facility to close all dampers in a single operation. And then you go on, each ventilated lobby will be provided with a key override. Now those are the little yellow key override switches that we'll look at in due course. A key override switch located within the stairwell at each story level, providing the fire and rescue service with a local override facility to open the dampers on any one floor. Once one switch has been activated to open the dampers on a given floor, then all other floor switches will be locked out. Once the activated switch is returned to its original position, another floor can be activated. So that's explaining what the different components of the system would be and some of the controls. And then if we could also go on to look at page 18. Sorry, actually, I think that must be a wrong reference. I'm looking for section 3.3, where the section's mechanical function is explained. Yes, thank you. So here is page 18. Yes, it says the mechanical fan set under 3.3 mechanical control system. The mechanical fan set will be provided with a fan starter panel, incorporating inverter speed drives to control the speed of the fans between low speed and high speed. So just to be clear, low speed was all doors closed. High speed was the door on the fire floor open, yes? And that's the stair door open, is that right?
Yeah.
So there's just 2 speed of fans, low and high.
Mm-hmm.
The open closed door condition will be monitored by a pressure sensor, which will measure the pressure differential between the lobby and the stairwell. The system is designed to maintain a 25 Pascal in the lobby with all doors closed, and will maintain the fans at low speed setting. Once a door to the smoke affected lobby, and only the smoke affected lobby, I think it should mean opens, the pressure differential will be lost and the fans will automatically ramp up to full speed to extract air from the lobby at a rate which will provide an average face velocity of 2 meters per second across the open lobby stairwell door.
Yeah.
So that's explaining what we were just discussing about the fact that once the stair doors opened and there's a change in the pressure differential and some of that differential is lost, the fans have got to ramp up in order to get your velocity of 2 meters per second across that stairwell door, yes?
Yes.
Now, is it correct that it was essentially this basic design, the bits that we've just read, that did culminate in the final PSB technical submission, revision 6?
I would think so.
Yes, that's as we understand it. So Now can we go to MAX 404665? MAX 404665. So this is an email from Matt Cross-Smith of Max Fordham to Claire Williams at the TMO. You're not a recipient or copied in here. It's dated the 24th of November 2014. And in essence, what this email tells Miss Williams of the TMO is that PSB and JS Wright had been part of a meeting earlier that day with Building Control, Ryden, JS Wright and Studio E all present, and that Building Control had in principle accepted the proposed design. If we look at the first paragraph, it says, we had a meeting this morning with Building Control regarding this proposed smoke extract system with Ryden, JS Wright, Studio E and the smoke extract system supplier PSB. JS Wright have developed a slightly updated proposal with PSB, which would eliminate the need for the fresh air inlet, which was previously at the top of the glazed foyer. It would instead take the makeup air from a vent at the head of the stair core. We've yet to receive a technical submittal for this, but in principle, it appears to be a neat solution which also satisfies Building Control. Now, do you recall this meeting on the 24th of November 2014?
I recall attending a meeting of that date. I don't recall the detail of it, though.
Do you remember Building Control being part of that meeting?
Yes. I think it was at their offices.
Now, is it right that the proposal being put forward was this pressure differential proposal that you had prepared for Max Fordham?
Not in that, we keep coming back to this particular point. If you looked at my technical submission, its base document is the Max Fordham's justification exercise for betterment. And that's what we discussed at that meeting. But it was based upon the principles that we set out, yes. But it's based on betterment, not a design solution.
So were those words used to Building Control, that this was a betterment proposal, not a...
I wasn't party to those meetings where that was agreed, so I don't know.
I see. So is it your understanding that prior to this meeting, it had already been determined that what you were looking at doing is simply bettering the existing system? Is that right?
Prior to us tendering the project, yes.
And can you explain what did you say to Building Control at this meeting about the proposal you were putting forward?
We were asked to describe its operational function and how it would work.
And how did you describe that to Building Control?
I'm not sure what you mean. How do we describe it? We went through what would happen if a fire occurred in an apartment and smoke got into a lobby. We described a sequence of events.
I see. So you described the extract process and you described the velocity across the door and the door opening force and the fans changing. All of that was explained to Building Control, was it?
Yes.
And did you get the impression that Building Control understood the type of system that you were proposing at this meeting?
Definitely.
Was it made clear to Building Control that this was a bespoke solution which didn't replicate any other building that you'd ever worked on?
It wasn't a bespoke solution, it was a betterment.
What do you mean by that? It wasn't a bespoke solution, it was a betterment.
As long as you were able to show the system delivered 3 cubic meters a second, then that was acceptable to Building Control. A betterment exercise was carried out by Max Fordham in conjunction with Building Control. They were asked to justify the amendments they were making to the system, and that's how the justification was made, that what was going to be put in was better than what was already there.
So why wasn't that a bespoke system solution for the practical problems that you were presented with?
Sorry, can you repeat that question?
Wasn't that just a bespoke solution for the practical constraints you were presented with?
No. As long as you achieved the 3 cubic meters a second, it didn't matter how you achieved it.
Well, I think it would help me and perhaps others Mr. Mahoney, if you could just expand a little on what you mean, because you've used the expression several times, as a distinction between a design solution and a betterment solution. Could you help me?
Okay, what the employees' requirements for the project were, that the original system as installed that was not operating should be refurbished and brought back to an operational standing. That's all you had to do to comply with the employees' requirements. Alternatively, you could put forward a suggestion that would put a system in that would be better than what was already there, therefore a betterment. Now, what Max Fordham did was put forward a document that showed how the proposed 3.5, as they put in their document, 3.5 cubic meters a second was better than what a natural ventilation system would achieve. They did a calculation, and what the boost facility fan would give. And I think my memory serves me well, it's something like 1 cubic meter a second for natural, 1.2 cubic meters a second for the boost facility on the existing, and the new system would deliver 3.5. Therefore, 3.5 was better than 1.2. It was better.
So have I understood it correctly if I say that you weren't asked to design anything? What you were asked to do was to enable Max Fordham or J.S. Wright to establish that the system that they were going to put in would result in an airflow at least as good and probably better than that which would have obtained under the original system.
That is correct. However, what I would like to qualify at that point to say is that it was always my intention that what was put in would be a workable solution to the best of our ability, given the constraints of the employer's requirements that made it impossible to put a compliant system in.
Yes.
Then you could not follow any of the standards. However, I use these strange terms, they're unique to me, not to the trade. And that is, what was the spirit of the standards? What were they trying to achieve? And I applied the spirit of the standards because I could not apply the standards.
I think that's very helpful. Thank you. Yes, Ms. Grange.
Yes, and did you ever look at the new system through the prism of the functional requirements in the building regulations? We talked about B1 and B5. Did you ever ask yourself whether the new system was making B1 any worse or B5 any worse?
As I said earlier, my opinion is that if it was to be CFD modelled, it would show that to be the case, that it is based on delivering ignoring a safe travel distance for a moment, because that's a different issue. If you put a standard mechanical shaft system in that building, if you're able to do that, it would deliver the same answer volumetrically that I had put in, but I achieved it a different way because I couldn't put a single shaft in with a single grill. I had to adopt 4 shafts with 4 grills. But the delivery requirement of 3 cubic meters a second would be met, but be met in a different way.
I see. Okay. Thinking back to that meeting, was it your understanding that building control in principle accepted the type of system being put forward by PSB and JS Wright at this meeting?
They accepted it, yes. Because when we talked through the principal operating factors and what would be delivered, it was acceptable to them, right, because they complied with the betterment that they'd given.
Do you recall building control saying at that meeting that they needed to be provided with details about what the extract rate for the system was, i.e. the extract rate through the vents in the lobby? Do you recall that being said?
No, I don't.
Now, if we move forward in terms of how the design developed, you've explained at paragraph 39 of your first statement, if we could pull that up, page 9. What you do in this part of your statement is you explain some of the changes that were made in subsequent revisions to the technical submission. Now, is it correct that these included the smoke shafts were extended down to the ceiling of ground floor level with vents into each of the communal lobbies on the lowest 4 floors, yes?
Yes.
And is it right that the specification was also changed so that the specification and location of the smoke extract fan sets were incorporated into the design, involving a change from having a single rooftop extract fan serving both north and south shafts to having one smoke extract fan in the rooftop plant room and one at lower level at the walkway level. Is that correct?
That is correct, yes.
Yes, and I think that's what you were explaining earlier, that originally the fan sets were both going to be at the top of the building, and then there was a change to make one of the fan sets at low level and one at high level.
That's correct, because the first meeting on site with Max Fordham was to establish how we would actually connect the south and north shafts together. That was the purpose of that first meeting on site.
Yes, I understand. Now, did this change in the arrangement of the fans for the system have any impact, in your opinion, on the system's likely performance?
Not in its likely performance, no, but every time you overly complicate something, you just have something else that could go wrong.
And what do you mean by that? What was the complication here which might result in something else going wrong?
Because we had to isolate a fan set from the environmental fan set, so you're introducing more dampers than we would normally have had.
Yes. So I think what you're explaining is that at the lower levels, because of the way the environmental system worked, that would have its own set of dampers. And then when the system's changed over from environmental to smoke control mode, those dampers would need to operate and different ducts would need to open up for the smoke control mode, yes?
Effectively, yes. We would normally have had one damper to isolate that fan set. As it turned out, we needed more than that because we had to isolate that fan set from the system and then the smoke extract from the environmental system when that was working. So we had additional dampers.
Yes, and I think the thrust of what you're saying is the more dampers you have, the more potential there is for maybe one of those dampers to fail and the system not to operate correctly.
Indeed.
Yeah. Now that meant also, it's obvious, that the design for the smoke was to be extracted in the south shaft downwards through the south shaft, the smoke to come down, not to rise up.
Yes.
In your view, did that fact alone affect the likely performance of the system?
No, it wouldn't. And back to a point, I know it's like I'm splitting hairs. It's not a smoke extract system. We're extracting air, potentially only air, or air and some smoke. So extracting downwards is not a problem. It doesn't give you any additional issues to deal with.
I see. So you didn't think that it might be a problem that once there was smoke in that south shaft, that smoke might rise up in the south shaft rather than get pulled downwards?
It wouldn't rise up if you had an extract fan running.
I see. Did you have any concerns about relying on the existing location of the south shaft dampers in the lobby for extracting smoke? We know that those south shaft dampers and the grills for them were at floor level, low level, whereas in the north side, they were higher up on the wall. Did you ever consider that as part of the design process?
I did consider it, but as they would assist in delivering the 3 cubic meters a second stroke 2 meters a second across the open door, then that would be acceptable because they were not there to extract smoke. They were there to extract from the lobby. It's not a smoke control. It's a smoke control system, not a smoke ventilation system.
I think what you're saying is it wouldn't matter if there was smoke at higher level in the lobby, as long as some air was being extracted at low level, the design intent was satisfied.
That is correct.
Yeah.
By preference, I would prefer it at high level. And if you look at the guidance, it says it should be at high level. That's my comment that I could not put a compliant system in.
Yeah. Now, if we go to revision 2 of the PSB technical submission, this is at PSB 401236 at page 3. This is dated the 14th of April 2015. And if we look at paragraph 1.1.2 at the bottom of the page, we can see it still says in the second paragraph there, it should be noted that the system is designed to extract air from the lobby, etc., and it's not designed to comply with all the requirements of the aforementioned code of practice. Now, if we go to an email now, PSB 50569.
Before we go off this particular document, could we go to the top of it, please? Can I show you something
Yes.
that I think is relevant?
You mean the top of this page?
Particular page, yes. If we look at item 1.1, sub-item 2, specification, Max Fordham Grenfell Tower ventilation analysis revision A dated 6th of May 2014 is the betterment document. So my specification is based upon Max Fordham's betterment document.
I see. Okay, thank you. That's helpful. So if we could go now to an email chain, PSB 50569. This is an email from David Bradbury within PSB to you on the 11th of June 2015. And he says, Paul Hanson from Building Control has just called. Can we let him know ASAP if we mean the statement highlighted in yellow, or can it be deleted and resubmitted? He wants us to basically delete it as it doesn't tie in with what we've discussed with him. If we can respond quickly, we can avoid him rejecting the technical submission. And we can see that he's highlighted that paragraph that I just read to you about what the system's designed to do, and it's not designed to comply with all the requirements of the aforementioned code of practice. And revision 3 for the transcript, I don't think we need to go to it, PSB 50209, that paragraph was then deleted in its entirety and doesn't appear thereafter. Do you recall that?
Yes.
Now, looking at this email here, can you help us? Why did that paragraph not tie in with what had previously been discussed with building control? Did you understand why that was being said?
Well, reading it again, it's very badly written. What I meant to say was that we were extracting air from the lobby and that makeup air come via, excuse me, the stairwell door, which it didn't quite say that, does it? But that's what was meant. Now, the reason I put it in there, as I said earlier, was it was something that myself and Dave Bradbury had a discussion, and I was concerned he didn't understand what I was saying. That's why I put it in there. So we didn't have to come back to it again. I know that when we went to the meeting with building control, they understood what we were saying. So taking it out wasn't an issue.
Yes, now I understand why you're saying that first part of that sentence was not as clear as it could have been. But what about the part which says the system is not designed to comply with all of the requirements of the aforementioned code of practice? Did you understand why there was a request for you to take that out?
I think it's because the statement is wrong, isn't it? It implies I was extracting from the stair.
Well, I understand that about the first part, but you're making 2 points in that sentence.
I was satisfied that building control knew what we were saying when we had that meeting.
Why were you happy for the part to be deleted which says the system is not designed to comply with all the requirements of the aforementioned code of practice? Because as I understand your evidence, it wasn't designed to comply with all the requirements of that code of practice. So why wasn't that a statement that needed to be in there?
Because we discussed it with all the relevant parties and they were happy with it. They understood after my discussions.
So is what you're saying that they understood through discussions that it didn't comply with all the requirements of that code of practice? So you didn't need to say it in this written document?
That's correct.
But wasn't that something that the technical submission needed to make very clear for all future readers and users of the system, that it didn't comply with all of the requirements of that code of practice?
But if you read the document in line with all of the document, it's clearly based upon a betterment. It says at the very front of the document. So the design principle is to achieve 3.5 cubic meters a second.
Are you saying that all readers of that document would have understood without that statement that it didn't comply with the requirements of that code of practice?
I can't say that, the same as I can't say that anyone who knows anything about smoke control at all would know it's impossible to put a pressure differential system into that building. But anyone who knows smoke control would know that.
Can we look at what you said in your first witness statement for the inquiry at paragraphs 50 and 51 at this point? This is on page 15. You say here, the PSB design was for a depressurization system. In other words, a system which achieves smoke control using depressurization principles achieved by mechanical extraction. BS-EN 121 Part 6, 2005 is the relevant standard for designing pressure differential systems, including depressurization systems. It sets out functional objectives and measurable performance criteria. Now, do you still hold to what you said there, that standard, that British standard, is the relevant standard for designing depressurization systems?
So that standard, yes.
And if we go to paragraph 52 of your first statement, below that, you say this: I drew upon the principles in this standard to develop a building appropriate solution. And then you say this: the PSB design was in line with the performance criteria of BS-EN 121 Part 6, 2005. Now, that's simply not correct, is it?
No, because the full stop shouldn't be there. The primary performance criteria of the design requiring a minimum of 2 meters a second. That dot there, I believe, is because it's come from the title document. But no, it's right.
No. So when you told us in your first statement that the PSB design was in line with the performance criteria of BS-EN 12106 Part 6, that was incorrect, wasn't it?
That is incorrect.
Yeah. And at paragraph 54, you told us achieving the functional objectives of that British standard indicates compliance with the functional requirements of the building regulations. So you've said the design was in line with that British standard, and achieving the functional objectives of that British standard shows compliance with the building regulations. Now,
In line with my design proposal, yes.
I beg your pardon?
In line with my design proposal. I drew upon the principles in this standard to develop a building appropriate solution. It wasn't following the standard, it was an appropriate solution.
Yes, and then
I said all along you couldn't put it in, so we've developed an alternative design solution because nothing else would go in.
Well, if we can look at your second statement to the inquiry at page 7, picking it up at paragraph 36. In your second statement that we received this year, you say mechanical extract systems which create a depressurized adjacent space, in this case the lobby, resulting in an induced airflow across the open door, can be referred to as depressurization systems.
Correct.
And then below that, you say these types of systems should not, however, be confused with pressure differential systems, which are designed to comply with all of the requirements of that standard.
Correct.
And then at paragraphs 39 and 40, if we go over the page, you say a decision had been made, this is 39, before PSB were instructed to make use of the existing shafts. It was not possible to make the shafts any bigger or install new shafts. I was therefore asked to design a system which reused the existing shafts, etc. And then you say at 40, it follows that I did not design a pressure differential system, which are designed to comply with all the requirements of that standard.
Mm-hmm.
Now, can you just explain how you came to say in your first witness statement that the design was in line with the performance criteria of that standard, but then you've told us in your second statement that you did not design a system which complied with all the requirements of that standard?
As I said, that's not what I said. That full stop was in the wrong place. It was the 2 meter a second I was referring to. And I'd made the statement that we used it to develop a system type. It wasn't following it. It was designed, we used it to come up with a different solution.
Can you explain why you didn't make that clear in your first statement to the inquiry, that you hadn't adopted all the performance criteria of that standard and that you'd adopted what you call a building appropriate solution?
No, I can't.
What was it that prompted you to serve that second statement on the inquiry some 2.5 years after your first statement? Did you suddenly realise that the first statement could be read as suggesting you'd complied with that British standard when in fact you hadn't?
It could be read that way, yes. But there are other things that have occurred since then and now.
But was that one of the reasons why you chose to serve a further statement in order to clarify that point?
I'm not sure that was my intent.
I see. Mr. Chairman, I see it's 1 o'clock. I think that's an appropriate moment
Yes.
for a break.
I agree. Thank you very much. Well, Mr. Mahoney, we're going to have a break now so that we can all get some lunch. We'll resume, please, at 2 o'clock. And again, I must ask you not to talk to anyone about your evidence or anything relating to it over the break. All right?
Okay.
And
Thank you.
we'll look forward to seeing you again at 2 o'clock.
Look forward to it.
Thank you very much. Good. Thank you. 2 o'clock, Miss Grange.
Thank you.